So, to begin, I can't imagine a time certainly in my lifetime, when it's been more important to talk about promoting better health. This has always been the case, but it just seems more prominent now than ever. And certainly, I think it's safe to say that better health is why we're all here today, in part because of COVID-19, but of course, in a transcendent sense, better health is what we all seek in our jobs every day. But why MCBK? Why this meeting? Why MCBK in pursuit of better health? And it starts by thinking about what the K stands for at MCBK. And of course, it stands for knowledge. And as we have developed this movement, we have come to think about knowledge in a very, very specific way that we think serves the purpose of this meeting very, very well. And that is to think about knowledge as a result, as you see on the slide, of an analytical and or deliberative process that holds significance for an identified community. So to expand on this definition a little bit more, we can look at some examples of biomedical knowledge. And as you go down this list, they move from types of biomedical knowledge that are primarily analytical in origin to primarily deliberative in origin. So predictive and explanatory models, computable phenotypes, causal and propositional networks. And now as we move toward the deliberation component of the origin of knowledge, we move into best practice guidelines, decision trees, and policies. All of these are examples, in our view, shaping MCBK's mission of biomedical knowledge. Another key point of departure for MCBK is a sense that there are two complementary ways to represent knowledge. On the left is the tried and true human readable representation of knowledge in words, pictures, and equations, things we can read in language and symbols and understand. And in anticipation of the session to follow our keynote a little bit later this morning, what libraries of the present have been focused on in fulfilling their missions is the curation, management, and dissemination of human readable knowledge. But we are anticipating a future where human readable knowledge will be complemented by knowledge in machine executable form. In other words, knowledge in code that machines can execute. And this form of computable knowledge will be the purview of libraries of the future. Again, anticipating a session a little bit later this morning. Now moving to why knowledge is important in the larger sense of improving health. Many of us believe, and in fact, I hope everybody on the in this session believes, that better health requires continuous improvement. And many of us view this model for continuous improvement through the lens of learning health systems. And if you look at continuous improvement through the lens of learning health systems, your attention quickly turns to cycles of continuous improvement focused around health problems of interest, each cycle focused on a specific health problem of interest. And in this cycle, improvement results from a progression beginning with performance to data, P to D, moving to data to knowledge, D to K, moving then to implementation, bringing that knowledge to performance, K to P, and then back learning from the experience of implementation and feeding the next iteration of the cycle over which continuous improvement is possible. We want to point out, and this is very, very important to MCBK, that MCBK is focused on addressing health problems across a range of domains, certainly including healthcare, but also including public health. And of course, we're seeing in COVID-19 how important public health is, also including research. And there will be a session focused on research later this morning, and also on education. We need to keep in mind that there were 4 problem domains of interest to MCBK. If you then view this learning cycle and juxtapose it with knowledge, you can think about knowledge because it sits at the junction point between D to K and K to B, P, as the keystone that holds knowledge together, sitting there at 12 o'clock and metaphorically, as well as substantively, holding the cycle together. And therein lies the problem. Without a keystone, there's a gap. That gap between D to K, the creation of new knowledge, and K to P, the application of that knowledge to improve performance, has vexed us for decades. And not only that, there is a widespread belief that the width of this gap in time, in other words, the latency between the discovery of new knowledge that can improve health and its widespread application to practice or performance, is of the order of magnitude of 17 years, plus or minus. It is a wide gap, and it is essential that we be able to span it and reduce it, and that is one aspect of what MCBK is all about. This brings us to the fundamental MCBK proposition. MCBK rests on the proposition that closing the improvement gap requires computable knowledge at that keystone point. That human readable knowledge will not get us there. And this is fundamentally the point of departure for MCBK. Expanding on that, we need an infrastructure. We need an ecosystem. We need a scalable infrastructure to support this improvement at scale using computable knowledge. And this brings into sharp focus the role of libraries of the future, to curate, manage, and disseminate computable knowledge. So libraries very much sit at this keystone and point and can be viewed as essential to holding this cycle of improvement together. Now, why do we need this? Heretofore, we've relied on systems designed for discovery to support improvement, and this is why we have the gap. Systems that rely on human readable knowledge operate in sequential form. Somebody does a study, publishes a result in a journal. Somebody else reads that study, publishes that in a journal, and somebody else reads that study and does his or her own research and publishes that in a journal. And what you see here is a serial process of discovery that requires only mass access to knowledge in order to function. And human readable knowledge actually serves that purpose quite well. However, if we want to implement an improvement system that operates rapidly, and in order to operate rapidly, it must operate in parallel, this requires a sort of mass action that human readable knowledge cannot support. To enable this agile mass action, persistent computable knowledge is essential. So to close my remarks, and the goal of my remarks has been to set the stage for the meeting that will occupy us over the next 2 days. I want to close with the point that we probably are sitting, and in my opinion, we are sitting on the verge of a second knowledge revolution as we move from the heritage of the first knowledge revolution, which has led to and enabled mass access to human readable knowledge, but which can only feed sequential processes, to a new dependence, reliance on computable knowledge, which can enable the kind of mass action that will enable continuous improvement at scale and get us to the point where widespread health improvement is possible across the 4 domains that I referred to earlier. This concludes my introductory remarks. I now turn the presentation over to Rachel, who will talk about MCBK and this year's meeting. Thank you very much.
Wonderful. Thank you, Chuck, and welcome everybody. And thank you for joining us today. Let me get my slides advances. So what is MCBK, Mobilizing Computable Biomedical Knowledge? We're a multi-stakeholder movement to mobilize computable biomedical knowledge. As you've shared with us the importance of doing this and the potential impact we can have. To date, we're in our third year now. We had an organizing meeting at University of Michigan in Ann Arbor in 2017, and many of the participants of that meeting have moved on to serve and continue to serve on our steering committee. We've had 2 annual open public meetings, both at the NIH in the summers of 2018 and 2019. We have 4 work groups, which formed during that first meeting and have been working continuously since, and I'll describe those in a moment. We have a number of web resources. So we have a page, mobilizecbk.org, where we post the videos, minutes, reports from our public meetings, as well as some of the work groups, videos on what is CBK, what is MCBK, papers, et cetera. We also have, due to the gracious support of University of Michigan, file sharing and some listservs so that we can coordinate across these different work groups to move our agenda forward. We've hosted a number of webinars, and those 2 are available on the webpage to try and pull in and coordinate with different stakeholder groups and potential partners here. And there's a number of national and global collaborations that Chuck will touch on at the start of the day tomorrow. So we've got a lot of activity in just this short time. The premise and foundation of MCBK is this manifesto, and this is also available on our website, and I will encourage you to access it and read it if you haven't already. The foundation is really the principle that health decisions really should be informed by the best available evidence at the appropriate time, place, and that this evidence and knowledge should be available to those that are making decisions. With all the advances in computer power and health information systems and health information technology, there's just tremendous potential to move knowledge right to the points of care or healthcare decision making where it's needed the most. And we want to create an ecosystem to make sure that this can be done safely and effectively. And there are a number of principles that support our work in our main objective, which is to make computable biomedical knowledge fair, findable, accessible, interoperable, and reusable. So this is our foundation. This was developed initially by our steering committee and internal planning team, but then went out to the participants prior to our first public meeting in 2018, and then incorporated feedback in a number of calls for input. And then what you see really is a collaborative and consensus document from our community.